All right, guys, last thing, classifying conics. On the test, on a standardized test, really anywhere, if you run across a conic, it might not be labeled as what it is. So you've got to be able to look at the equation and decide for yourself, well, what am I graphing? Because the methods for graphing a circle versus a parabola versus an ellipse versus a hyperbola are all quite different. So this is what your book outlines. If you have A and C equal to one another, you know you have a circle. If you have a parabola, then A times C is going to be 0. Why is that? Well, in order to get a 0 out of multiplication, right, one of them would have to be 0. And what do you know about a parabola? Only one squared term, right? So one of those would have to be 0. In an ellipse, both A and C are positive, right? And in a hyperbola, one of them has to be negative. Think about how we just set them up, right? We talked about the positive square term being the transverse axis and the one that's being subtracted. Well, that would mean that if you multiply A and C together, you'll get a number less than 0. I don't really have it memorized quite so mathematically. In a parabola, you've got one square term. In an ellipse, both squared terms, there's two squared terms, and both of them have positive leading coefficients. If you happen to have a circle, it would be because your A and your B value, right, your axes are the exact same length, which amounts to them having the same coefficient on the square terms. And lastly, the hyperbola, if you have two squared terms, there's an x squared and a y squared, but one is positive leading coefficient, one has a negative leading coefficient, then you know you're dealing with a hyperbola. So I pulled out a whole bunch here. They don't even really show up on the homework necessarily, but you could glance at them and hopefully decide really quickly what they are. In fact, you might want to challenge yourself to go ahead and turn off the video and see if you can label them yourself. Take a minute. It should only take you, 30 seconds for each one, probably 10 seconds. And then turn it back on. Okay, hopefully you did that exercise. Right, the thing that I noticed about this one, I only have one square term, right? So that makes this guy a parabola. For the second one, you have an x squared and a y squared term, but you have a positive 4 and you have a negative 1 for your leading coefficients. So that makes this one a hyperbola. For letter C, right, x squared, y squared, so both of them appear. Positive 2, positive 4, your coefficients are both positive, so we are dealing with a ellipse. And if you answered ellipse here, you're 80% right, but because they both have 2's, if you actually went through the process and did the division, you would have an A and a B that are equal. So this guy is a circle. Here, you have an x equals y squared, so this one would open right and left, and it would look like a parabola. X squared and y squared can't be a parabola, right? But one of them's got a negative coefficient, so that makes this one a hyperbola. Positive coefficients, x squared and a y squared, you're dealing with an ellipse. And last but not least, looks like we have another circle, right? X squared, y squared, same leading coefficient, both positive. This guy is going to be a circle. Your homework for today is the Hyperbolas worksheet. It's got lots of practice with graphing, and we'll spend some time in class tomorrow going over any questions that you have, and I have a little bit more practice with coming up with equations for you. So we'll spend 2 days on these. I would try them out so that you can use the time in class tomorrow to ask questions and to work with your friends. Thanks for watching.